And an interesting thing to know here is the product of any n consecutive numbers is divisible by n factorial. So say, I'll start this way. We say 2 is divisible by 6, right? And we can show it symbolically this way. 2 divides 6, or 2 is a factor of 6. So what I can say is product of any n consecutive integers is divisible by n squared. So 4 into 5 into 6 into 7 will always be divisible by 4 factorial, which is 24. And based on this, we can say something. Say n is a natural number, then n into n squared minus 1, which is nothing but n into n minus 1 into n plus 1. Product of 3 consecutive numbers. This is always divisible by 3 factorial, which is nothing but 6. Okay. And next we have Fermat theorem. What Fermat theorem says is, given any whole number a, and so a belongs to the set of whole numbers, and say p is a prime number, then Fermat theorem states p divides a power p minus a. This is Fermat's theorem. So we can say, given any natural number, n cube minus n is always divisible by 3. So n power 7 minus n is always divisible by 7. And make a note, p must be a prime number. And now let's discuss about base conversion of numbers. We were discussing about a binary system, octal system, hexadecimal system, and most commonly used decimal system. So given a number in say binary system, how do you convert to a decimal system? And given a number in decimal system, how do you convert to a binary system? Or say given a number in binary system, how do you convert to an octal system? So in all these conversions, one thing which we take for reference is the decimal system, because that's something which we are really very comfortable with. We are not comfortable with binary numbers, we are not comfortable with octal numbers. So let's first start with converting a binary number into a decimal number. Let us say we have a binary number 1 0 1 1 0 1. When we have this number, to make it clear that this is a base 2, we show it this way. So we need to convert it into a number of base 10. That's a decimal number. So it's very simple. What we do is, a number of base 2 is converting to decimal is nothing but take the last number 1 plus the last but one number 0 into 2 power 1 plus next number 1 into 2 square plus the next number 1 into 2 cube plus the next number 0 into 2 power 4 plus the next number 1 into 2 power 5. So it goes 2 power 0, that's 1, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So this is the base 10 number. So let's just compare. 2 power 5 is 32, and this is 0, and this is 8, this 2 square is 4, 0 plus 1. So this is nothing but 55. So 55 to base 10. So this is how we convert a number binary to decimal system. In the same way, let's say we have a number 1 4 6 of base 8. We need to convert into a decimal number. So in this case, what we do is, we need to convert into base 10. which is nothing but take 6 as it is, plus multiply 4 with 8 power 1 plus multiply 1 with 8 square. So it's nothing but 64 plus 8 into 4, 32 plus 6 base 10, which is nothing but 1 or 2 base 10. And now let's take a hexadecimal system. Let's say the number is 1A3, and this hexadecimal system is 16. And here one thing which we need to note is the symbols we use for hexadecimal system are 0, 1 till 9 plus A, B, C, D, E and F. And 0 to 9 have the same values as we have for the decimal system, and A has a value 10, B has 11, C has 12, D has 13, A has the 12, oh sorry, yeah, 10, 11, 12, 13, E has 14 and F has 15. Okay. As you have seen, the octal system has 0 till 7 and hexadecimal has 0 till 15. So let's convert 1A3 base 16 to a number of base 10. So we'll start with the last number 3 plus, and last but one number A. A is nothing but 10 base 10. So 10 into 16 power 1 plus 1 is 1 itself, 1 into 16 square. So this is nothing but 256 plus 160 plus 3, which is nothing but 419 to base 10. This is how we convert numbers from a different base system to decimal system. Now let's see it the other way. Let's say we have a number, say 17 to base 10, and we need to convert it to base 2. So in that way, we start with the number 2. We start it this way. You divide it by 2. You write the quotient and remainder. You once again divide this coefficient with 2 again. We need the base 2, so we are using it 4. The remainder is 0. And once again you divide it by 2. You have 2 and 0. And once again you divide 2, you get 1 and 0. You continue the process till the quotient you are left with is less than the base number we are looking for. Say if we are looking for a base number 8, we will continue the process till we get a base number of 0, 1, 2, 3, 4, 5, 6 or 7. Now this number 17 to base 10 converted to base 2 is nothing but the number we get in this order. So 17 to base 10 is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1 to base 2. Okay. And let's say we have number 238 to base 10. And now we need to convert this to a number of base 8. So we continue the same way, 238 divided by 8. So it's 2 and 9 with the remainder of 6, and you further divide with 8, get 3 with the remainder of 5, and 3 is less than 8. So 238 to base 10 is equal to 356 to base 8. In the same way you can go with the hexadecimal system too. So what I do is, let's say we have same number 238 to base 10, we need to convert into hexadecimal system. So we say 238 16. So this will be 14 times with a remainder of 14. and 14 is less than 16, so that's all. And 14 is e, so this is nothing but e to base 16 in this way. So we saw how to convert a different base system to a decimal base system and a decimal base system to a different system. What if you need to convert, say, an octal number to a decimal number or any other thing? In this case, what we do is first we convert to base 10 and then convert base 10 to 2. That's all about base conversion.